Make sure your neighbor is okay with these. When you come to a good stopping point, or if you need some help, maybe get some help.
Yeah.
We ready? Just about ready? I'll give you about 13 seconds. Starting now. Yeah, I saw you on the track. Barely saw you. You're so fat. Almost blurry. Emma too. I've seen you a couple of times. I saw her yesterday.
I had practice this year, and then I had.
Well,
It was a long day.
so you're so fast you didn't see.
Yeah. Were you there yesterday?
No, I've been in church, so I was like cosplaying at this shot.
Okay. You're speedy too, right? I see you up there.
Elle is, look at Elle. Elle is insane.
I don't really see you up there.
And Simran.
So many runners.
She went.
Okay, the warm up. Please show me your answer to number one. This better be super familiar to you. Yeah, exactly. How many points do I want to see on a good graph of this? 3. Specifically, I want to see, like, most importantly, 0, 0, the vertex, and then 1, 1. Like, if you just did this, I wouldn't blame you because it's just a warm up. I'm not grading it, but it sure is frozen. Thank you. Sorry about that. So I want to see that and that if this were like a test or a quiz, and then these two. So 5 points out of the up 1, then up 3 for each one. Are we good? Okay, for this next one. Oh, what kind of function would we call this? Quadratic, which is under the umbrella of what kind of function? Right, it is a parabola specifically, but under the umbrella of a larger type. What is it? Polynomial functions, right? Polynomial function. Is this a polynomial function? Definitely not a polynomial function. This is called exponential. Could you please trace this on the whiteboard in front of you with your finger? Exactly, just goes like this. And in this case, one of the most important points that I'd want to see is the point at 0, 1, where we see that anything to the 0 power is 1. And from there, I answered my own question. I would want 2 more points when x equals 1, x equals -1. Of course, when x equals 1, y is equal to 2. And when x equals -1, y is equal to 1/2. Are we comfortable with that? 2 to the negative first is 1/2. And this gives us a nice shape here. It goes up like this, then down like this. And for this one, is this a rational function?
Oh,
It is not. It's the base is a rational number, but it's still exponential. Please show me what this one looks like. Yeah, and this one also crosses through the point 0, 1. If I plug in a 1, I'd get a 1/3. If I plug in a -1, I get a 3. Something like that. You have this on yours? Okay, very nice. We're talking about concavity. For these, you would say that the number 2 is concave up. Do we agree with that? And for number 3, it's also concave up. So decreasing and concave up. So, but they are definitely both concave up. Okay. Today's notes won't be in the packet, but you could look at the packet later if you want a little bit more enrichment. But today, what's going to happen is this is not brand new for you, is it? Yeah, I'm going to go very quickly go over a lesson and then give you time and class to do the assignment. Assignment's a little bit longer than normal, but you're gonna have a ton of time to finish it. Most of you will probably, I'm sorry to say, be able to finish it in class.
This the assignment is the homework.
The assignment is a homework, so the online homework.
One pizza. Does that mean?
Yeah, so-
Are you?
It means I haven't gotten to the rest.
Okay.
Yeah, so for tonight, I know it's Pearson. Thank you for looking. Okay, so let's talk about exponential functions.
Pretty funky.
So the most basic of exponential functions, it would be in the form f of x equals b to the x, or some number to the x, where b is a constant. Would you just check in with your neighbor to see if they remember the restrictions on what b must be? Can't be any number.
Negative? Wait, no. Yes. You cannot be undefined.
Not wrong. Just don't know what that means. Can't be a horse.
Can it not be zero?
Yeah. It can't be one.
Yeah, I
Then
can.
it would just be one.
But it can make
Okay, so what are the restrictions on b?
Yeah, because it
Can't be real. Jonas?
can't be 0, 1.
Well, let's go one at a
It
time.
can be 0. It can be 0.
Let's say it can't be 1. Why can't it be 1?
Anything like 1 to the power of n.
Exactly. 1 to anything is 1. So it wouldn't have that nice growth or that decay that we saw. So it can't be 1. And also b, not only can it not be 0, it can't be negative. So it comes with understood that b has to be greater than 0. Right? Those are the restrictions on. So there are two types of equations, and we already talked about them in warm-up. What's that? Let's talk about y combinatorial in just a moment. Good question, though. So if b is greater than 1, I want to see 3 points. Anytime you graph an exponential function, I want to see 3 points. And the main one is kind of like the vertex, except it's not a vertex, 0, 1. The other point I want to see is 1, comma
0.
1, comma 1, comma b. Now, what do we know about b? In this case, it's greater than 1, which means I'm just going to put it randomly up here. Now, I have no idea what my scale is here, so I'm just going to say that this is 1, comma b. And if I plug in a -1, I hope it makes sense that b to -1 will give me a value that is 1 over b, which is
Less than.
between 0 and 1. Does that make sense? If b is greater than 1 and then take the reciprocal of it, it's going to give you a number that's less than 1. Specifically 1 over b. So I'll put that over here, 1 over b. So -1, comma 1 over b. I'm not going to put the coordinates on that other one. So we have this nice exponential function graph, which you're familiar with already, at least from the warm-up. The other case is if b is, I'm not going to say less than 1, I'm going to say b is,
Bigger than 0, but less greater than.
the word is between 0 and 1. So, okay, so my graph now, I still have that same point. When I plug in a 1, do you see where my y value is going to be?
So it's going to be between 0 and 1.
It's going to be between 0 and 1. It's going to be like down here. And this is now b. This is 1, comma b, isn't it? And if I plug in a -1, it's going to be 1 over b, except because this time we're starting with a number between 0 and 1, we take the reciprocal of it, like 1/2. The reciprocal of that brings us to 2. So it's going to bring us to here. And in this case, the coordinates are still -1, comma 1 over b. This does say 1 over b. Let me make it like a human wrote it. It's +1 over b. So I want those 3 points anytime you're graphing an exponential function. Yeah. The one and only Jonas did ask a really good question. I want you to discuss with your neighbor. Why do we not have this as an exponential function? No need to write it down, but unless you want to, but why is this not an exponential function?
Oh,
Wait.
I personally don't. Basically, go down to one and then I'm dead.
Or just be like, yeah, I wouldn't really cause it.
Okay, show me in gestures the reason that you the problem in gestures. What's that?
It's kind of just go everywhere.
That makes sense. So it kind of go up and down because
Because of the sign.
yeah, when you raise a negative number to an even power versus an odd power, it's going to change signs, won't it? So first, it would kind of quickly lose properties of that exponential graph that we talked about. So that's one problem with it. And there's another huge problem. Did you discuss what the other huge problem is? The one problem? What do you mean the one? Well, the y-intercept, -2 to the 0 power is 1. It's true. What's that? Okay. There is a big problem. I think you're onto something. I think you're onto something, but specifically, did you find it?
It would, oh, I know. I know.
You know?
Can't take the square root of a negative number.
Where does square roots come from?
If you do like
Right.
x to the power of 1 over like 5. Like if you
What?
make x like
I don't think
1/5.
Well, let's try 1/2 before 1. Yeah, what does -2 to 1/2 mean?
The square root of negative.
Yeah, then we get an imaginary number, and you're right. If we did something like -2, if we did like try to do like 1/10 or something like that, these are big problems.
These are big.
These are big problems. So we just don't want to have those headaches. That's why the base of our exponential function must be positive, just so we don't have to deal with all that. We want our functions to be well behaved. So,
Error.
kind of to connect this to what you were saying, although it would have a y-intercept, like what would be just to the left or just to the right? We don't know. Crazy stuff would happen. We don't want craziness. We want peace, serenity in our math. So we just try to keep things well behaved. So that's why we keep that base positive, like our attitude. But please discuss this with your neighbor. Don't write this down, just discuss.
That's okay, because the negative is outside, and therefore you're basically saying -2. You're basically saying -2. And that would just be branch like that.
Yeah. It's basically negative odds. Yeah.
Yeah.
Okay, well, it doesn't work.
If you like take 2 here and put like parentheses over it, and that's the negative.
5 more seconds. Hey, is this okay? What does that negative do? Reflects over the x-axis. So that's fine. The base is not, the base is still positive, but that would just be a reflection. I'm going to talk about one more function, then I'll give you some time to do some work. F of x equals a times b to the x. Take a moment to discuss with your neighbor what that a does to your function. Hey, show me, what does that A do?
Just.
It depends. And now it's outside the function, so it's going to either do this if A is
No, it's
greater than 1, or it would do this
Less
It's-
than 1.
between 0 and 1. And of course, if we're negative, it would do this, right? It would just flip over that x-axis. So I'm going to have one more graph here. I'm going to say that A is greater than 1 for this. So on my function, I really now only care about 1 point. Do you know which one I care about? Yeah, it's no longer 0, 1. It's now 0, A. Does that make sense that it's been stretched up to be A no matter what it is, either stretched or compressed? So it's going to look something like this. And that's why A is called the, do you know the name of this?
coefficient.
It is a coefficient, kind of. What is it? Think about its role in the graph.
Percent. The.
Initial.
Its initial value. Is that what you're thinking?
I was gonna say that, but then I thought it was okay.
Does that make sense? That just is the initial value for this exponential function? And B is called it's repeated multiplications. So it's a factor, but specifically it's either a growth or decay factor. These things sound familiar? Okay, I'm going to want to talk to you again in about 15 minutes, but until then, I'm going to give you some time to take out your laptop and get started on the assignment. Are you excited? I just want to talk to you a little bit more, but I don't want to get in the way of your progress.